Okay, here we go. On the past few days, we've looked at right-hand sums. We found areas of rectangles. We need to switch that up a little bit. So today, a little bit, kind of a let's pull together what we've done and extend a little bit forward. But if we examine the right-hand sums, what we did is we kind of divided that up into, a certain number of of x values that we identified the heights. And so I'm going to call this first one x sub 0. I'm going to call this last one x sub n. And so we would have x sub 1 and x sub 2 and so on and so forth. What will be the one right before x sub n? X sub n minus 1. So when we use right-hand sums, just recall that we are finding the height at the right hand of the subinterval. So we determined that in order to find the area or approximate it, we take the width times the sum of the heights, right? We add up all the heights. So if I want to find the first height, do I type in x sub 0 or do I type in x sub 1? X sub 1, we've always gone to the right, correct? So it'll be f of x sub 1 plus f of x sub 2 plus dot, 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 plus what would be the last one? Yep, f of x sub n. Maddie, why is your face all red? Why are you... Okay, so I'm not going to write all the x's down this time because I think you'll get the idea. We also have what we call left-hand sums. And so notice our first subinterval here. If we're doing the left-hand sum, where do you think we evaluate the first height? Do you think we type in x sub 1 or x sub 0? Yeah, you type in x sub 0. So you have the width times f of x sub 0. There were some whispers. Plus f of x sub 1. So notice you're going to pick up the x sub 1, aren't you? So it's very similar to the right hand. You also pick up the x sub 2. But what's the last one you have? Yeah, you stop at x sub n minus 1. So plus dot, 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 plus f of x sub n minus 1. Good. Then we have this thing called midpoint sums. Midpoint can be a very accurate, estimation. X sub 0, x sub n. I have the width times, if we look back to our original drawing, anybody want to guess what we try to do to evaluate the first height? Hint, it has to do with midpoint. We find the middle of these two. We take x sub 0 plus x sub 1 and we divide it by 2. So you don't have to draw this down, but I'm going to show you an example so you can really appreciate what's happening. Suppose that I have this as a picture, and I have, say, x sub 0, and I have x sub 1. Watch what happens with my right hand. If I want to look at a right-hand rectangle, do I draw it at x sub 1 or x sub 0? X sub 1. Overestimation or underestimation? Over. So you're like, okay, well, we'll try a left hand in order to get a better estimation. So I go left hand and I draw at x sub 0. Over or under? Under. So you're like, well, let's try the midpoint. So the midpoint is x sub 0 plus x sub 1 divided by 2. It's the average of those two values. So what you do is you draw the height here. So this is the height, and then you draw it across to both those spots. So does that look like a better estimation? Yeah, because you have, this is your overestimation, right? And then this is your underestimation, and it almost looks like they could go together, doesn't it? So in order to come up with a midpoint, we average the two values, okay? And we get the over and the under in many situations. So that's what happens there. So if we go to our notes, we have, where are you? That guy and back here. There we go. F of x sub 0 plus x sub 1 divided by 2. And then the last one would be f of x sub n minus 1 plus x sub n all divided by 2. And then, for people watching the video, again, I know that if you were to look at a book, you'd see something different for trapezoidal sums, but we're going to come back to trapezoidal sums later on this year when we get the AP exam. There's a really easy way to come up with trapezoidal sums, and I'm going to use this picture to try to help you again. If we have, say, x sub 0, and we have, let's call this x sub 1. Remember what I showed you kind of the first day we were investigating this? We started to look at the rectangles, and we said, well, the red one is an overestimation. That was right hand. The left one is the blue rectangle. That's an underestimation. And we said we would like to average them, right? So if we were to average the right hand and the left hand, what shape do you get? A trapezoid. You can see that when you average the right hand and left hand, you get the trapezoid. So for right now, instead of talking about the definition of a trapezoid, which trapezoid would do what? 1/2 times the height times the sum of the bases. That's our formula for area of a trapezoid, right? We're just going to use a very simple approach right now and say, well, it's going to be the left hand sum plus the right hand sum divided by 2. So once we find the left hand and the right hand, we can then divide by 2. It might seem intuitive to you that the midpoint would in fact be the average, but that's not the case. It's the trapezoidal. Okay, it's the trapezoidal. So let's try some examples and stop with kind of the notes and start to figure this out. Here we're given a table that says use the following table to determine the appropriate approximate area bounded beneath the function over the interval -2 to 6. And these are the notations that you will see. This means right hand with 4 subintervals, left hand with 4, midpoint with 4, and trapezoidal with 4 subintervals. So what is the width of the entire interval? 8. So if we have 4 subintervals, what's going to be the width of each one? 2. So I have 2 times. And we have our first interval is -2 to 0, then 0 to 2, 2 to 4, 4 to 6. Where do I evaluate the first height? On the right side, so I evaluate it 0, and what's the height at 0? 1. Then 7, 8, 6. So I get 8 plus 8 is 16, plus 6 is 22, times 2 is 44. Is that where we're going? That's how I fix my 2's into 4's. Sorry about that. 44. There we go. Fancy 4. Okay, so what's going to happen differently for the left hand? Where do I start evaluating it? Yeah, I started -2 and I get a value of 5. Now notice, what values am I going to have as well that right hand has? 1, 7, and 8. 1, 7, and 8. What gets left off? The last one. You see that? So I get 5 plus 1 is 6, and then the 15, that makes, what do we got there? 21 times 2 is 42. Sweet. Once I have the right hand and the left hand, I can do the trapezoidal. Trapezoidal is simply the average of the two. What is the average of the two? 43. Look at that. Is that nice? Now the midpoint is different, okay? The midpoint is going to be the average. So I want you to look here. What's the average of -2 and 0? What's the -1? So we evaluate the height at -1, which is 10. And then we go from 0 to 2. What's the average of 0 to 2? 1. We evaluate that height, we get 5. Average of 2 to 4. And I get 16. Average of 4 to 6 is 5. We get 5. So we've got, what, 72? What do you think? Could you do a table example? Excellent. Flip it over. Okay, so we're going to skip example 2. It's not that important right now. We look at example 3. Now we are given a function, -x squared plus 16. Approximate the area bounded between the curve -x squared plus 16, the x-axis, and the y-axis in quadrant 1. So I have the first quadrant. What does -x squared plus 16 look like? Yep. Up here at 16, anybody know where it crosses the x-axis? That will be important. 4, very good. See how much math you know. All right, so I need to find right hand of 5 intervals. So what is the width of the entire interval? 4. How many subintervals are there? 5. So what's the width of each interval? 4/5 or 0.8. So notice how I'm going to draw this out. I start at 0. I go over 0.8 to get to 0.8. If I go over 0.8 more, I get to 1.6. Then 2.4. Then 3.2. So to show work in this situation, let's use our calculator for some of it. But we'll do f of, for right hand, what would be the first x value we plug in? 0.8. That would show me that you know what you're doing. And then f of 1.6, f of 2.4, f of 3.2. Do I stop there? I go to f of 4, right? Because if we have 5 subintervals, we need a total of 5 heights. Okay, so let's take out our calculator. There's Dwight, ready to brighten our day. Okay, so here we go. We have the function. Let us now go in and type our values. We start by typing 0.8. And we type in 1.6, type in 2.4, 3.2, and 4. We knew for 4 you would get 0. So those are my values I'm going to use as I add them up. And after I add them up, I multiply by what? 0.8. So I have 0.8 times 15.36 plus 13.44 plus 10.24 plus 5.76 plus 0. And if I do that, 0.8 times 15.36 plus 13.44 plus 10.24 plus 5.76 plus 0. And you can see 35.84. Now, I've tried to set you up so you can take some shortcuts here. You should be able to find the left hand pretty quickly because most of the values stay the same, don't they? Please take a minute, try to find the left hand and the trapezoidal. Once you find the left hand and the trapezoidal, it should be very quick. We'll do the midpoint together, okay? Go, try to do that. Okay, boys and girls, can you tell me how the left-hand sum was slightly different? You pick up 16, and then you have the 15.36, 13.44, 10.24, 5.76. What do you leave off? The 0. And we multiply what you get? 48.64. Any questions on that? Can we now find the trapezoidal? How? 35.84 plus 48.64. We divide by 2. What'd you come up with? Is everybody okay with that? Okay, then we have to do the midpoint. So the midpoint, there's no easy way to do it. You actually have to decide what are the values you plug in. So what is the first value I plug in? 0.4. What's the next value you plug in? 1.2. Folks, notice. What's the distance from 0.4 to 1.2? It's 0.8. I'm increasing by 0.8 each time. The next one should be 2. The next one should be 2.8 and then 3.6. You now have your x values. Go ahead, type them into your calculator. See if you can come up with your new height. The fact is it should be, the midpoint is most similar to the trapezoidal sum. Those two are most similar, okay? So you should hopefully come up with something close to that 42 route, okay? Go ahead. Okay, great. So we're going 42.88. You see that that's much closer to trapezoidal than it is to the left or the right hand. Okay, now we're going to evaluate the sums over the interval from 0 to 120, with this being f of x. What is the length of our entire interval? 120. So if we have 4 equal subintervals, the width is 30. So we have 30 times. I need right hand. So what is the height at the right hand of this interval? 40. 80. Good. 20. 100. So let's see, that's 100 there, so 200, 240, 240 times 3, so 7,200. Cool. You go ahead and take care of the left hand and the trapezoidal. Go. So I noticed that the left hand we lose, for the left hand we lose the 100 and we gain 0, right? So that's a change of 4,200. But we knew that the right hand was an overestimation. This was definitely an underestimation, isn't it? So the trapezoidal sum would be the average of the two, which would be 5,700. Let's do the midpoint together. The midpoint together. Look at the middle of the interval. What is the height at the middle of the interval? 20. So that rectangle represents that area. So I've got 30 times 20 plus what appears to be the height at the middle of this one? 60. I got 60. That'd be great if she was taking calculus. You know, at this point in her life, she needs some help, so she turns on Mr. Gens's YouTube video and she hears Sam say 60. Boom! Yeah. Thank you for bringing us joy, YouTube sensation you are. Okay, now, what's the middle of this one? Yeah, I'm going to say 50. That's a good call there, everybody. And then how about this one? Middle is, yeah, I'm going with 60 on that guy as well. Good job. So 60 and 60 is 120. And then 50 is going to be 170. And 20 is going to be 190 times 3. I got 5,700 on that guy. Yeah. Yeah. Turns out, and if you think about it, the midpoint and the trapezoidal should be the same as is a linear function. So my good friend Ashley said this seems rather simple. I can do it. That's excellent. Take out your calculator. Let's try to do something more challenging. This is our last example. You've done a great job. Take out that calculator. Which, by the way, you can't do this next one without a calculator. It says, find the area bounded between the curve f of x is sine of x and the x-axis over the interval 0 to pi by constructing 100 rectangles. Find the right hand, left hand, midpoint, and trapezoidal. Right 100. Well, I'm not gonna put it there. I'm actually gonna put the graph over here. Everybody remember what the sine graph looks like? It's a wave. What's the period? 2 pi. So we're looking from 0 to pi. So is that the area where sine's above or below the x-axis? Above. So we're looking at the sine function where it's above the x-axis. We're wondering that exact area right there. Can somebody tell me what's the width of the entire? Pi is the entire width. How many rectangles? How many subintervals? 100. So what's going to be the width of each rectangle? Pi over 100, right? We all just say the width is equal to pi over 100. Wouldn't it be a pain in the butt to do all 100 by hand? Let's try to find a good way to do it. You get to use your calculator when you get to these examples where there's like 100 or 50 or 200 rectangles, and we're going to come up with a really, really close approximation here. Going to y equals plus sine of x. Is everybody good to go there? Because you're going to learn some new operations here. These are ones you have not learned before. We got to make sure that you know what the heck you're doing. Okay, next thing we're going to do is we are going to quit And you're going to type this in. Sum, parentheses, sequence, parentheses, y1, comma, x, comma, beginning, comma, end, comma, width, double parentheses. So I'm going to show you now how to find all these spots. All we're going to do is we're going to use our calculator to help us add up the heights more easily. On the beginning of this, just put in width times. This is width times the sum of the heights. That's what we're doing. Width times the sum of the heights. So we're going to teach you what your calculator is going to help you do so you can do this rather quickly. This would be a pain in the butt to do them all by hand, right? So your calculator is going to do this amazing thing for you. There's other ways to do it. This is kind of one that I created. I like the way it works. So we're going to start with the width, which is what? 1 divided by, or I'm sorry, pi divided by 100. Everybody good? Times sum. The way we find sum, everybody focus here because you won't remember this otherwise. Second catalog. We want to get to the S's, so what do you think we press? S. And you scroll down until you get to sum, and you want the lowercase sum. Right here. Everybody okay there? Okay. Now we need to type in sequence. Same thing. Second catalog. What do you think I press now? S. Into SEQ. Press enter. Now, we want to evaluate our heights, right? So we plug x values in. What do you plug your x values into? What's our function? Sine of x. We put that into our y1, right? So we're going to tell what do you use for height? Use the function sine of x, which is y1. Press bars, bars, bars. Bars means variables. Go over to y bars or y variables. You want your function variables, press enter, and you can select y1. You got through the challenging parts. Everything else is easy. If you got through that, the rest is easy. Everybody got it? Okay, we press comma. Comma button is above your 7. All right. Now, so we've got that. So we've got our comma. Now we press X. Nope. Where's our beginning, folks? What is, no, not 0. We're doing a right-hand sum. Pi over 100 is our first spot, right? So we're going to do, our beginning is second pi divided by 100, comma. Where are we going to end? All the way over at pi. So second pi. And then finally, our width. What's our width? So pi divided by 100 and double parenthesis. Okay, and folks, if you make a mistake, you can insert, you can delete, you do all sorts of things. I'm going to show you a way. After you get the answer, don't press clear. I'm going to show you a great way to bring this all back very quickly, okay? So we press enter. Let's see what we get. It's thinking, it's thinking, it's thinking, it's thinking. Ooh, look at that. Time out. wait, pause. Slow down. I know what's happening. Everybody pause. Hit mode. Go down. Press radians. Now, second quit back to this screen. Now watch. Go second entry. It will bring the same thing back. So you have to retype it all. And press enter. So the right hand is of 4. So right 4 is going to be 1.9998835, whatever. I'll tell you what you need to round to on the test, but right now let's write a bunch of them just so we can see the difference between the two. I want to do left hand sub 4, and so this is going to be much, much easier. You guys have the general idea, but I'm going to actually show what I'm typing in here, okay? So I'm typing in 1 over pi times the sum of the sequence, right, of y1 and x. Now, what's my beginning? My beginning is 0. That's what changes with the left hand, right? What changes my beginning? So I begin at 0. Do I go all the way to pi? Pi minus pi over 100, right? You're going to back off pi over 100. So to pi minus pi over 100. And then what's our width? Pi over 100. That's going to be your left hand. Question. I'm sorry. Pi over 100. The reason why it's 1 over pi is because I used that 3 times today in a different class. So it's sticking in my brain. Sorry about that. Pi over 100. All right, so let's just press second entry to bring it all back. So you don't have to change anything now until this pi over 100 piece, right? And you just press 0, comma, pi minus pi over 100, comma, and then pi over 100, double parenthesis. So I save myself some time, right? And now we're going to press enter. It's going to think. And we get a very similar answer, 1.998849. So it's a little bit different, isn't it? Yeah. Could we now do the trapezoidal sum? The trapezoidal 4 will be the 2 averaged together, right? But before we do that, I don't want to use, all I want to do is I want to continue to use this guy. So we're going to do the midpoint first because I've got this in my memory up there, don't I? So let's do the midpoint, and then you've seen it through. The midpoint of I'm sorry, not 4, of 100. So this is where people really start to get confused. This is everybody said this was pi over 100, right? That was your first step forward. Everybody agree that this is 100 pi over 100. So then this spot right before it, as Maya said, was pi minus pi over 100, or 99 pi over 100. We agreed? So who can tell me what this spot, the middle of 0 and pi over 100, would be? Pi over 200. Anybody know what the middle of 99 pi over 100 and 100 pi over 100 is? It's 199 pi over 200. I will show you so that you understand. Remember, what we do is we add them and divide by 2. What is 99 pi over 100 plus 100 pi over 100 divided by 2? Can you see how you get the 199 pi? And you see when you divide by 2, you get the 200? So there we go. We have our beginning, we have our end, don't we? So let's go to our calculator. You've done a great job. Long lesson today. Second entry. I go back to the 0 and I change it to pi over 200, comma, 199 pi divided by 200, comma, and pi over 100. So the midpoint of 100 is 1.999588. I've now done all the commands I need to. So I could go ahead and average these other two, 1.99835 plus 1.998849. And divide that by 2. And the trapezoidal of 100 is 1.9985995. Anybody want to guess what the actual area underneath that curve is? It's exactly 2. It's exactly 2. Did I forget one? Sorry about that. You're absolutely right. 1.99835 plus 1.9988 divided by 2. You're very, very right. 1.999342. I saw my answers like that doesn't look right. Good work.